So the Financial Times first moved to AWS in 2013. We started with one AWS account, which was shared by dozens of teams. It did give us a lot of benefits, but we quickly found out that there were a lot of security problems that we didn't really think about with a shared account architecture. We were really frustrated because it was getting really hard for us to keep track of production incidents happening. But today, we have smaller, cleaner AWS accounts, and this talk is going to be about how we managed to turn it around. I'm going to talk a bit about about our journey from moving away from our data centers to using AWS. I'm going to talk a bit about the problems that we faced with a single account architecture, our motivations from moving away from a single account to multiple accounts, and finally, I'm going to talk about how did we make sure that the resources that we created in our AWS accounts were compliant to FT standards. Hello, I am Jermila Dhas, and I'm a senior engineer at the Financial Times. I currently work in a team called Cloud Enablement, and we are responsible for building tools and solutions to run and govern large AWS and Heroku cloud estate. We also provide delivery teams tools to encourage thinking about costs when they build infrastructure. And we're currently on the lookout for a cloud engineer to join our team. If you do like working with Python, if you like AWS config, EC2, Lambda, and a lot of other AWS services, please feel free to come and have a chat with me after this talk. If you want to know more about what the job involves and what I do on a day-to-day basis, please feel free to come and ask me questions. But we do have a lot of other positions open. Please feel free to take a look and come and have a chat with me later. So moving on to the fun stuff, so how did it all start? It was 2011, and we had that. So this is a picture of our data center, and we absolutely hated it. We were not really a big fan of it at all because A, it was occupying a lot of space, and B, it was costing us a lot of money in terms of operations and maintenance. So in 2012, we started talking about AWS, and we were really passionate about it, and we thought we'd give it a go. So why did we do that? So one of the problems that we had with our data centers is that was because it was very expensive. Again, we were spending money in terms of operations and maintenance. And we thought, if we do move to AWS, we could make use of AWS's on-demand cloud computing platform and its pay-per-use features, which could probably save us money in terms of operations and maintenance. And we also did not like the traditional way of purchasing additional storage and servers for unexpected growth. It did not work well with a lot of delivery teams because we had to rely on different teams to set the hardware up. And we wanted to move to AWS because it would give us the ability to create resources. We would have the power to scale resources up and down based on business and application needs. This is an interesting graph. This tells you how long it took us to roll a service into production in 2011, which is when we were relying on our data centers, versus 2014, which is when we completely adopted AWS. As you can see, in 2011, it took us 120 days to roll a service into production, and out of which 40 days was just spent on setting up hardware. Whereas in 2014, it took us a couple of hours to push a service into production, and we really, really liked it. And one good thing about AWS is it gives you the flexibility to experiment with evolving methodologies, such as microservices. So all good things, right? Finally, with AWS, we thought we would have two layers of security. The first layer of security being offered by AWS themselves, and the second layer of security can be customized by us, which was probably an added bonus. So in 2013, we got ourselves a brand new, shiny AWS account, and we had more than 30 teams using that new AWS account. And just 1 year later, we ended up having more than 700 EC2 instances. It was very hard to keep track of who owned what. We had more than 250 terabytes of data in S3 buckets. Again, we had no clear resource ownership, which made cost attribution very, very difficult. We had more than 300 users logging into our AWS account, and we had more than 300 IAM users with wider permissions just running around in our AWS account doing its own thing, which we didn't really like at all. And We also managed to lose our one of the team's production clusters, but just for a very short time. But we nearly lost a lot more. So what had happened was our alerts went off, and we realized that a team had lost its production cluster in the EU region. One of our developers were running an Ansible playbook that was terminating instances based on a team tag rather than an environment tag. If it weren't for that team tag, we probably could have lost a lot of instances that would have belonged to other teams. And we had our website, our membership platform, and our content platform running in that AWS account. And that's when we realized that the shared account setup was not really working for us at all. There was just a lot of risks involved, and the first and foremost being security. And we thought, it would be really great if we could reduce the blast radius in event of a security breach by having fewer resources, by having fewer users logging into an AWS account, and by having fewer access keys running around. And we also wanted to give least privilege access to data and resources within those AWS accounts. Cost was still a concern. Cost has always been a concern. We wanted a clearer resource ownership for better cost attribution. So in 2014, we moved from a single shared account architecture to a multiple account architecture. And today, we have more than 600 workloads running across more than 50 AWS accounts. Our delivery teams were absolutely excited because they got their own brand new AWS accounts, and we gave them flexibility to do whatever they want to do with their accounts. But what we realized was with delivery teams, the main concern were to get things done, and cost and security were not their first and foremost concern. So we implemented a few rules to make sure that the resources that they create were compliant to certain restrictions, and we started with security. We started by restricting access to AWS accounts based on AD groups using SAML. The way we did that is every team would have its own AD group. Let's say I'm trying to log into an AWS account that my team has access to. What I do is I browse to the ADFS site. ADFS is Active Directory Federation Service. It is a Microsoft software that enables single sign-on access for systems. And the sign-in page would authenticate me against AD by asking me to enter my AD credentials. Then my browser is going to receive a SAML assertion in the form of an authentication response from ADFS. And then my browser is going to post the SAML assertion to the AWS sign-in endpoint, requesting temporary security credentials and a sign-in page. And finally, my browser would receive the sign-in page, and it would take me to the management console. Now that we have restricted access to our AWS accounts, we wanted to restrict permissions on what users can do with the resources in the AWS accounts that they have access to. And we used rules to do that. And as you can see, we have two rules that we use, the FT engineer rule and the FT IAM admin rule. By default, all users who have access to log into an AWS account would be able to assume the FT engineer role. And as an FT engineer, you would be able to create resources, say EC2 and a Lambda, but what you would not be able to do is you'd not be allowed to make changes to an IAM policy or a security group change. So if one were to make potentially risky changes to security groups or networking changes, we had allowed only a few named users, and those users have to be AWS certified. By doing so, we managed to restrict access to data and resources in our AWS accounts. And now that we have secured access to our accounts and our resources, we wanted to identify the critical resources which were of security concern and costing us money, and then we figured out those resources were EC2, IAM, and S3, the usual suspects. And then we realized, back in the days when we had one account, it was really hard for us to manually go through every single resource that we have running in our account to see if they're compliant. And now that we have more than 50 accounts running for the FT, it's going to be even harder if we were to do things manually. And we thought, if we were to police things across more than 50 accounts, we wanted to do it consistently, and we wanted to do it with less manual intervention. So we wrote modules that checks compliance of resources, and we deployed across all the AWS accounts that we have. A module consists of a resource definition, which is the desired configuration of an AWS resource. We have a Lambda job that checks the desired configuration of the resource with its actual configuration, and then it reports on it, and it sends the results to a service called AWS Config. For those of you who do not know what AWS Config is, AWS Config is a service offered by AWS which evaluates the configuration of an AWS resource. What it does is it automatically evaluates its desired configuration with its current configuration, and it reports on it. This is how an AWS Config dashboard looks like. If you want to evaluate a resource, you would be creating config rules, and every config rule would evaluate a certain configuration of a resource. And here you can see that we have 2 config rules with a few non-compliant resources in that config rules. So let's take IAM as an example. IAM, also called as Identity Access Management, is used for controlling users' access to AWS resources. When we had one large account, we had more than 300 IAM users running in our account, and most of the users had wildcards in them. And as we all know, wildcards can be very destructive. We had our resources running our website, our membership, and our content platform running in that account. We had already lost a production cluster once, and we didn't really feel like doing it again. So after moving to smaller accounts, we gave IAM admin privileges to a few named users who own the account, and they'd have to be AWS certified. They were allowed to create users, they were allowed to create roles and policies, purely because we managed to reduce the blast radius in the event of a production issue or a security breach, because that's confined within your own AWS account that you have access to. But unfortunately, wildcards in policies were still a thing. So we implemented AWS config rules to make sure that the IAM policies and the users that were created by users comply to certain restrictions. So these are the config rules that we have currently in place that looks at IAM resources. I am not going to go through all of them. If you do want to learn more about every policy that we have in place, come and feel free to have a chat with me after this talk. I'm just going to go talk about a few of my favorite ones. The first being, we encourage key rotation at the FT. We ask delivery teams to rotate old AWS keys. We have a config rule that flags keys that are 90 days old, and we have a service that comes in and deactivates your key if it's 180 days old. But we do give the team sufficient warning. This is an example of an email that gets sent to the team a week before the deactivation of the key. It tells the delivery team that you have a key that's going to expire because it's going to hit its 180th day mark. If you don't rotate it, I'm going to come in and I'm going to deactivate it. So all your services that relies on your key is going to stop working, so you might as well go and rotate it. So there was a huge uproar when we enforced key rotation at the FT. Our teams complained about the time that they are spending on rotating keys and updating the services. So we, because teams don't like change, I don't like change, teams don't like change, so that's fair enough. So we wanted to make it easier for delivery teams to do key rotation. So what we've done is we have a service called automated key rotation that automatically rotates keys for you after 90 days, after 70 days. And it's integrated with Secrets Manager. So it's nothing but a Lambda job. What we do is if we want us to sign our users up for this automatic key rotation service, we add the users to a IAM group. We have a Lambda job that looks at all the users that is a part of that IAM group, looks at its age. If the key is 70 days old, it goes in and rotates it. And it rotates the key, updates Secret Manager, and pushes out an SNS notification. And we have our end users who rely on that key, subscribe to the SNS topic, and they get a notification saying that your key has been rotated. This is a path for your access key and your secret access key in Secret Manager. Go and fetch your credentials and update your services if you want to. So we have started doing it. We We still haven't implemented the manual rotation of keys in their own key store, but this is just a beginning of what we could do for our delivery teams to make things easier for them. And my next favorite is wildcards. We implemented an AWS config rule to flag IAM policies that has elevated permissions on critical resources, let's say IAM or VPCs or S3 buckets. By elevated, I mean S3 asterisk on asterisk, meaning if you have an IAM user with S3 star on star, not only can your IAM users do destructive things on the S3 bucket that you own, but also can do destructive things on S3 buckets that doesn't belong to you, which is not really a good thing. So that brings us to our next resource, S3 bucket. So an S3 bucket, a public S3 bucket, is possibly at a risk of exposing personal and sensitive information to the public. So we implemented a config rule that flags all the S3 buckets that are public, and we report on it, and the main reason being GDPR. So what happens if an S3 bucket is public? We wrote a service and we called it the governator. The governator quarantines an S3 bucket, meaning the governator, if a governator finds an S3 bucket to be public, the governator comes in and applies a default set of bucket policies on your S3 bucket, which would restrict the access of objects within your S3 bucket to the users who have permissions to log into an AWS account. It also terminates an EC2 instance if it does not comply with certain standards, which I'll be talking about later. So to iterate, if we have an S3 bucket that's public, the governator comes in and picks up the S3 bucket, applies a policy on it, and restricts the access to the users who can log into an AWS account, just so that I can go in and update the access control list and the bucket policies so as to allow access to the objects within the bucket. And this doesn't happen immediately. We do give the teams a 24-hour window after window of the misconfigured bucket, but we do send them an email saying that you have created a bucket, but that bucket is public. Think about it before making it public. If you don't want to make it public, please apply a bucket policy. If you don't apply any bucket policies, we are going to quarantine it. Quarantine, in this case, it's going to be applying bucket policies. So once our teams have fixed permissions, in this case, you can see that a bucket is going to be quarantined. It says that the bucket policy will have a quarantine rule applied, meaning it's going to restrict access. And once the teams have fixed access to the S3 bucket, we send an email saying that your bucket is all good. We no longer are going to do anything to your bucket, and you're fine. And so these are the few things that we did to secure our resources. Now I'm going to talk a bit about our second concern, which is saving money. The first service that would spring to one's mind when you think about costs is EC2, because it's expensive. When we had one account, we had no way to figure out who owned what, which made cost attribution very difficult. So we encouraged teams to tag their EC2 instances with their team email, and if they didn't, in came the governator threatening to terminate your instances. But we do give the teams 2 hours before stopping the instances. So this is an example of an email that gets sent to a team. In this case, that EC2 instance that got spun up is missing a team DL, which is the team email tag. And it goes, if you don't tag your instance with the team distribution list, I'm going to go in and terminate your instance. And once our delivery teams have tagged our instances properly, it sends a follow-up email saying that, oh, your EC2 instance is all good and you're fine. So we basically did this because we wanted clearer resource ownership for better cost attribution. We also realized that we could save money by encouraging teams to move away from RHEL. We have an AWS config rule that flags all instances that is running on RHEL, and we encourage teams to move away from RHEL to Amazon Linux or CoreOS if using containers. We approximated the savings to be about $500 for every server that was migrated. This is purely in terms of license and operations. So that is a lot of money. And we also have an AWS config rule that flags instances that is running on an older generation instance type, we again encourage teams to migrate the instances from an older generation to a current generation purely to save money and to make use of the higher performance hardware. As an example of how you could save money by asking people to migrate, a few weeks ago, we migrated 30 servers from M3 large to M5 large, and we approximated the savings to be about $27 per server. And if I've done my calculations right, it's about $810 in total that we had saved. It might not sound like a lot, but it all adds up. So we also have a config rule that flags AWS volumes that are not attached to any EC2 instances, and we encourage teams to go in and clean up the unused AWS volumes, again, to save us money. And we also have a config rule that flags elastic load balances and application load balances that doesn't have any registered instance to it. So by deleting unused ELBs and ALBs, we approximated the savings to be about $240 per load balancer per year. And finally, we encouraged teams to turn their EC2 instances off when they're not using it, just the non-production ones, when they're not using it, which would probably be overnight and over the weekend. As we all know, EC2 is an on-demand service. You only pay for the server when the server is actually running. We even wrote a service to make it easier for the delivery teams to turn their EC2 instances, and we called it EC2 powercycle. The way it works is it is nothing but a Lambda job that is going to look for an EC2 instance or an auto-scaling group that is tagged with a tag of EC2 powercycle. The tag value of the EC2 powercycle tag would be a simple JSON document that has the start and the stop schedule in a cron tab-like expression. So the first example is a tag that you would apply to an EC2 instance. As you can see, that EC2 instance starts at 8, stops at 6, and it does that during the weekdays, and it stops over the weekend. And the second and the third tag are the tags that you would apply for an auto-scaling group. For auto-scaling groups, you would have to specify the minimum and the desired value of the auto-scaling group, and if you don't, by default, it assumes that the minimum and the desired value would be 1. And by turning off instances, we saved about 70% of the cost. So these are the few changes that we did to save the company some money. And then we thought it should be not the centralized team's responsibility, but everybody's responsibility to think about cost savings and compliance when they are creating resources. And we thought it would be great if we could create awareness about the amount of money that a delivery team is spending on AWS resources. To do so, we had to find a way to relate a resource to a service and a service to a team. So we introduced a system identifier called system code, which we use to identify a system at the Financial Times. Our definition of a system would be an application or a business or a technical service or an infrastructure component, say an EC2 instance or a load balancer or a database. And then the system identifier is then linked to a team, and the teams are encouraged to tag their resources with the system code to identify a system, and the team email to relate that resource to a team for better cost attribution. So what am I trying to say? Let's take an example. This is dashing. This is a tool written by Shopify, and we use that as our monitoring aggregation dashboard. This is the system definition of dashing, and as you can see, the system dashing has a system code of dashing, which is the system identifier. Teams will have to tag the instances on which dashing is running using that system code of dashing. We also specify the team who's responsible for looking after dashing. In this case, it's infrastructure delivery. So the cost of dashing will be attributed to the infrastructure delivery team. Now that we had a way of figuring out who owned what, we thought it would be great if we could create a pretty visualization of how much a team is spending. And this is Cloud Health. Everybody loves a pretty graph. So this is Cloud Health. Cloud Health reports on AWS costs. You can filter AWS expenditure and usage based on a team email or a system code. You can also generate reports on cloud health, and at the FT, we get it delivered first thing on a Monday morning because that's what we like looking at for some reason, how much we spent on our AWS estate. But the downside of cloud health is that it requires you to have an account, and it was hard for us to get everybody at the FT to get a cloud health account, so we created an internal tool called Smart Cloud Use. This is a dashboard for a team. This dashboard summarizes the AWS cost incurred by a team. It also gives you a visualization of your AWS estate, EC2 estate, and tells you how much a team can save if they migrate from RHEL onto Amazon Linux, which is the second graph. So this is how we created awareness about the costs incurred by a delivery team. So I spoke about both security and costs, and at the end of the talk. So as a final note, I would like to think that the FT took the nudge theory approach with regards to governance. There's a really nice talk about nudge theory by Sarah Wells, who's also the technical director of a team called Operations and Reliability at the Financial Times, and I've linked the link to the bottom of the slide. And she's also sitting on the second row here, and if you want to learn more about nudge theory, please feel to go and talk to her. For those of you who do not know what nudge is a concept in behavioral science and economics, which proposes indirect suggestions as a way of influencing one's behavior and decision-making of groups and individuals. At the FT, we are huge believers in empowering the teams to make the right technological decisions because an empowered team is a happy team and a productive team. So we gave the delivery teams their own AWS accounts and let them do whatever they wanted to do and got out of their way. But we also introduced subtle policy changes to encourage them to think about costs and security when they make decisions with regards to infrastructure. Thank you. If you have any questions, I'll be standing right here. Please feel free to come and have a chat with me about anything that I spoke about, or if you want to know more about the other cool things that we're doing at the FT, or if you want to know more about the roles that we have open at the FT right now. Thank you very much.